Section 5.4, Factoring Polynomials. What's a factoring? When you are asked to multiply 3 by 5, you get 15, which is the product. So going from here to here, it's called multiplication process. However, if I give you 15, and once you go back to 3 and 5, which happens to be the prime factors of 15, this process is called factoring. So if I had to define what factoring is, I would say not opposite, but the reverse. Operation, reverse, let's say, process of multiplication. How is that? Because I don't want to say opposite of multiplication. Opposite of multiplication is division, is that right? So I'm just going to say reverse process. So 3 times 5 is 15. But if I give you 15 and you tell me that that's 3 times 5, what you have done, you have factored the 15, correct? So what would be the factors which are called prime factors? Of course, what's a prime? Prime numbers are those numbers greater than 1. 1 is not a prime number. That they are divisible by 1 and themselves only. So those are prime numbers, like let's say 2, 3, 5, 7, 9 is not prime, 11, 13, 15 is not prime, 17, 19, and it goes. These are prime numbers. All right. So what would be the factors of 12? Well, 12, 2 goes into 12 6 times, but 2 goes into 6 3 times. So therefore 12, the factors of 12 is 2 times 2 times 3, which is 2 squared times 3. There you have it. What are the prime factors of 50? Okay, 2 goes into 50 25 times, but 5 goes into 50 25 5 times. So the prime factors of 50 is 2 times 5 times 5, which is 2 times 5 squared. What would be the prime factors of 32? Well, that would be 2 goes into 32, what, 16 times is it? 2 goes into 16 8 times, but 2 goes into 8 4 times. But 2 goes into 4 twice. So what are you saying? I'm saying 32 is 2 times 2 times 2 times 2 times 2, which is 2 to the power of 5. 1, 2, 3, 4, 5. Is that right? So with that in mind, how do you find the greatest common factor? The greatest common factor between two numbers is a number, the greatest number, which divides into those numbers with no remainder. So what would be the greatest common factor, which the acronym is GCF, of 8 and 20? Well, find the prime factors of 8, which happens to be 2 to the power of 3. Find the prime factors of 20, which happens to be 2 squared times 5. And now select the correct number as your GCF. So what you do, you select the common factors with the lowest powers, So between these two boxes, I see that these guys are in common. Both of the boxes have 2 to some power in common. Do you see it? Well, which of these 2 to whatever the power I have to select for my GCF, the one with the lowest, lower exponent. So between 2 to the third and 2 to the 2, which happens to be common between these two, what's inside these boxes, I select the one with the lower power, which is 2 to the 2. Therefore, the greatest common factor is 4. This is the greatest, the largest number, which divides into 8 and 20 with no remainder. That's why they call this greatest common factor. That means come up with the largest possible number which divides into your numbers. The numbers are given with no remainder. So the remainder has to be what? 0. So what would be the greatest common factor of 2x cubed, 6x squared, and 12x? Well, the greatest common factor between 2 and 6 and 12 is 2. That's the largest number which divides into 2, 6, and 12. However, between the x's, they all have x's. I choose the one with the lowest power. So the answer is 2x. That's the greatest common factor. What would be the greatest common factor of 20xy cubed, 6x squared, y to the 4, and negative 12xy to the 7? Well, between 20 and 6 and negative 12, I believe what? 2 is the greatest common factor. 2 is the largest number which divides into 6 and 12 and 20. Between the x's, let's see first of all, do all of these terms have x? Yes, they all do. Because if some do, some don't have x, then that cannot be considered as your GCF. Remember the magic word here, the letter C, means common. That means they all have to share the same letter. So in this case, you got x in every single term, so I choose the one with the lowest power. As far as the y's are all in common. I choose the one with the lowest power. So I would say the greatest common factor between these three monomials is what? 2xy to the third. Notice greatest common factor is positive. So now that we know what to do or how to find greatest common factor, I think now it's time to factor. Remember what factor does. It changes the problem into multiplication form. Multiplication form. So that's the job of factoring. It takes an addition or subtraction. It simply changes into multiplication form. That's what purpose of factoring is. The greatest common factor between these two terms is between 5 and 25 is 5. But greatest common factor is not x because this guy doesn't have an x. Remember, the C stands for common. X is not in common, so that's it. Now you have to decide what do you multiply by 5 to get these guys back. I guess you have to multiply it by x plus 5. So now the factoring has been completed. So there you have it. So what you see inside the box is the factored form of this what? Binomial. Notice it changed the addition into what? Multiplication. What about this guy? Well, they all have 2 in common. So that would be x squared minus 6x plus, excuse me guys, 3 what? Oh, plus 1. In other words, what's in front of the parentheses is always greatest common factor. What goes inside the parentheses is like, what do you have to multiply your GCF by to get all of these guys back? So in this case, that would be like x squared minus 3x plus 1, because if I distribute the 2, I get all these guys back. So this is the factored form of this so-called trinomial. What about this trinomial? Between the coefficients, I see greatest common factor is 3. Between the x's, I choose the one with the lowest, but make sure they are what? In common. Okay, between the y's, I choose the one with the lowest. Both of these guys has y to the first, so I'm going to choose either. Okay, not both. So here, I'm going to get x. Up here, I'm going to get 2xy. And here, I'm going to get 1. In other words, if I distribute this GCF by these guys, God willing, I should get what my original statement back. And I think I do, because that would give you 3x squared y. This gives you 6 what? X squared y squared, and that would give you 3xy. So there you have it, and that's how you factor this trinomial. What about this guy? Well, between 9 and 3 and 11, there is no GCF. If there is no GCF, that means what? They are prime. In other words, they don't have anything in common. So go ahead and find out what might be the greatest common factor of the x's. Well, we choose the one with the lowest power, so the GCF is x squared. So that leaves you with 9x squared minus 3x plus 11. Okay, just in case you were wondering how am I getting these terms inside the parentheses, the way I get those numbers or terms is I take the what? Original problem, like so. Okay, do you see it? And I simply divide each of these guys by GCF. Okay. So notice if I take like 9x to the 4 over x squared minus 3x cubed over x squared plus 11x squared over x squared, reduce these guys, I get 9x squared minus 3x plus 11. And that's how I get those terms inside the parentheses. Take the original problem, divided by GCF, then you can tell what goes inside the parentheses. But don't forget to have the GCF in front of the parentheses, yes? All right. So when the leading coefficient is negative, you would like to factor the negative as well. So yes, in this case, the GCF is 2, but the leading coefficient is negative. So it's customary to factor out a negative 2. So that would give you positive x squared, negative 2x, negative 10. There you have it. Once again, why am I taking negative 2 as opposed to positive 2 as my GCF? Notice I don't want the leading coefficient to be negative. Once you take the negative 2 out, notice the leading coefficient is now positive 1. Do you see? Sometimes we are asked to factor 4-term polynomials. Well, the way we do this, the method is called grouping them 2 at a time. Well, let's take a look at this binomial. So once we learn this, so we can then do 4-term polynomial. Check this out. You got 1 and 2 terms here. But what do they have in common? Looks like they both have this guy in common, so this is your GCF. The minute you pull the GCF out, then open a set of parentheses and see what's left when you take these terms away from these 2 terms. You take this guy out, what's left from the first term is x. You take this guy out, what's left is negative 6. And that's exactly what goes inside the parentheses, second set of parentheses. And ladies and gentlemen, we are finished with that problem. Once again, how do I know that I'm done with the factoring problem? There should be no plus or minus between your parentheses. Your final answer should appear in what? Product form. That's the purpose of factoring. If there is a plus or minus somewhere in between the parentheses, you are not done yet. Okay, now let's go back to what we said about factoring a 4-term polynomial by grouping. So what we do, notice neither of these 4 terms have anything in common. However, if you group them like 2 at a time, then each of the first two terms, they got something in common, like x squared. And each of the last two terms have something in common, like 3. So from the first two, I'm going to factor out x squared, and that's going to give me x minus 5. From the last two terms, I'm going to factor out positive 3, and that's going to also give me x minus 5. So remember, I had a 4-term polynomial. Somehow, when I grouped them and I factored, the GCF out of the first two, out of the second two, all of a sudden, I managed to change the problem to a binomial. Okay, so instead of 4-term polynomial, now I have a binomial. How do you know you have a binomial? Well, you got two terms, 1, 2. But wait a minute. Each of these two terms have something in common, and that's like they both have x minus 5, so factor that out. Open a brand new set of parentheses. And what's left if you take away x minus 5 from the first two guys? X squared. Take away x minus 5 from the next term, you get plus 3. And notice I still have multiplication sign between the parentheses, so that must be the final answer. Do you all see it? So do you see what the purpose of factoring is? To take an expression and convert it to multiplication form. Question is, why am I doing this for? Well, you will see in later sections. We need to factor polynomial to solve polynomial equations, higher degree. And in chapter 6, when we deal with rational functions, which is like algebraic fractions, that's what I call them, you need to know how to factor, to reduce them, to add them, subtract them, multiply them, divide them, or even solving equations with algebraic fractions. So that's the topic of chapter 6. Once again, this is a 4-term polynomial. So how do we do these guys? We group them 2 at a time. Even though overall they got nothing in common, but 2 at a time they do have something in common. Like the first two, they have x in common. So when you take away x, you get x plus 4. The last two terms, they got negative 5 in common. And when you pull out the negative 4, that also gives you x plus 4. But now this is a binomial. What exactly this binomial, these two terms have in common? X plus 4, so pull that out or factor that out as the saying goes and see what's left. What's left is x minus 5, final answer. Super easy sections. Thank you guys.